with Berlin interop updates. So we had an interop event last week. A large amount of time was spent on scaling the gas limit as well as Fusaka. But we did have multiple other tasks, tracks with history expiry, peer-to-peer changes, CL hardening, ZK EVMs, L2s, and quite a lot of other tracks. I think over the next week or 2 weeks, no, actually sometime this week before ACD, we should have a summary of everything that happened last week. But for now, I think we'd go into a bit more detail on two of the tracks, with Fusaka being the first one. We had all the specs and open PRs from last week merged into Berlinterop DevNet 2. This is a DevNet that's going to be up until next Monday or Tuesday, and the reason we use the Berlinterop name is such that so that we could make faster decisions without needing to go through the ACD process while we were in person. However, those changes will now go through the ACD process and will eventually end up on the Fusaka DevNet 2 once they've been cleared by ACD. That being said, Fusaka DevNet 1 is still live and will go down over the next day or two unless anyone specifically needs it. So if you do need it, then please speak up. If not, please move all of your testing to Berlinterop DevNet 2. And Fusaka DevNet 2 should come up sometime around next week. Any questions regarding Fusaka in itself? Okay. The second track that we spent a lot of time on was gas limit testing. I think most of the time was spent on benchmarking clients as well as optimizing performance. I think the outcome was great. We should have a deeper write-up come out later today. However, one of the things we soft agreed to on Friday was to raise the gas limit to 45 million. However, client teams would need to push in the fixes that they have in the performance branch as well as make releases for this. Is this something that we can have clients agree to do over the next week? Could we maybe get someone from each client team to speak up on this?
I hope you guys can hear me. I'm in the same room as Terry. No? Yeah?
Yeah.
Okay. Maybe it's better this way. Yeah, so for gas, we need at least one fix to get into master until we feel like we don't feel super vulnerable. There's a bunch of things where we think like going above 45 is not possible right now without changes to without repricings. But I think that like the biggest one is like the ModEx stuff that we are already addressing in Fusaka. So like from my personal point of view, 45 would be okay, but I'm not speaking for the team.
Now the mine's okay with 45. We would like to put out a new release, but I think we're comfortable with the current release. And signaling, I assume it won't be immediate anyway. And we have a release similar.
Thank you. Could we have maybe Roman and then Milan from Aragon?
Yep. Or comfortable going to 45 as is.
Yeah, Aragon is ready for 45 as well.
Awesome, thank you. Then I guess we'll share some more info on the benchmarks we did, as well as what bottlenecks we found over the next week. And once the client teams are have all changed their defaults, we should the network signal to a higher gas limit. Awesome. Marcin, I know you've been working a bit more on benchmarks as well as exploring gas limits a bit more. Do you want to talk about it?
Yes, sure. So like we know, like for the clients, the worst case is the ModEx. and it will be repriced in Fusaka. So before Fusaka, we have like we know what is our bottleneck, and when Modex will be addressed, then probably the next bottleneck is YAD. So it's performing good enough to go for 60 million. But if we want to aim in 100 million between Fusaka and the next Carfog, then we probably need to reprice in Fusaka too. And right now, I'm crafting more test cases for EC pairing and EC mul to check if it is performing good enough to keep the pricing as it is, or if we need to reprice it too. So far, I didn't find the test case which is performing like badly. So it doesn't look like there will be a need to touch it in Fusaka. And yes, do you want Pari to talk about some specific topic about benchmarking, or
No, I think that's a good update for now. I think for EC ad, we should also have an EIP up for that later this week. There is a proposal for what we want to reprice it to. And yeah, today and tomorrow, I guess Marcin and a few others would be figuring out if we do actually need to reprice EC mul or EC pairing going forward. This should help us get to 60 million and further and prepare for Fusaka, I guess. The other topic that came up was logs in themselves, either repricing or changing the dev P2P limit. I'm not sure if anyone has thoughts on that or has time to look into it. I know that there's a proposal from Julio, but I don't know if there's any more work being put into it.
I mean, this sort of kicks in more around 85 million, so we'd still be fine at 60. There's something we potentially want to, probably definitely want to fix in some way for Fusaka, but I don't think we've come to a conclusion on what the right way is yet.
Is there some specific data point or something we should look at that would help us get to that conclusion? Or is it just we need to discuss this on ACD and come to a solution there?
Well, I think we need to discuss on ACD. Probably a helpful data point would be to actually emit an entire block of logs and then see if there are any performance implications. And then maybe that would help us decide whether we want to reprice or increase the peer-to-peer.
Okay, got it. I think PK has a reproducible test for this already. He was able to break SnapSync locally. And I'm not sure if he looked at it from a performance perspective. I think he purely looked at it from a does this break SnapSync perspective. But we should have a test for this that we can reuse.
Yeah. I mean, I think there's at the moment, there's two obvious ways we can go, and having some benchmarks would probably inform which direction will be better.
Okay, we can clean that up and get it up to people. I think the other topic was Estor with large tree depths. I think this is something we noticed on blocks with Zen contract transactions. It again doesn't seem to be a major issue, at least for 45 million. However, as we move to 60 and forward, will definitely be an issue. I know last week Joachim was working on this a bit. Do you maybe want to go more into what the current status is? Do we have a reproducible test? Were clients able to trace what was going on their clients?
Yes, so this is about the Xen contracts, right?
Exactly, yeah.
Yes. So what it looks like is that it creates a lot of small contracts. These contracts which are being created are actually proxy contracts, so very small ones, which delegate call into something else. And what happens is that during this transaction, it's a transaction with a gas limit of 28 million, and it creates 167 small contracts, and it also does a lot of storage. It stores a lot of values there. I'm looking a little bit in if there is something else very fancy going on there. It doesn't really look like it. It really looks like it's a lot of create two or small create contracts, and that there's a lot of storage being dumped in there. And my hunch will be that the caching mechanism of clients, these key values, these are like cold, because you can't really predict beforehand in what addresses and what key values we are going to read or write. And I think that might be one of the problems why we have seen like very slow blocks. There is a state test, or I'm not sure if it was a state test or a blockchain test. I think a state test, which does exactly that. It creates a lot of small contracts, and it dumps random storage of not random, but it creates a random storage tree there. And I think what we have seen in clients is that the execution time of this state test is actually not, well, it's not very alarming. But on the not the DevNet, on mainnet, we saw that it was very slow for some clients. And this might be because it's like a very huge, of course, the state database is very big, much bigger than if you would just run a state test on like an empty or an almost empty database. And therefore, likely on mainnet, because the storage slots, not the storage slots, but the database reads, they are cold. This then likely takes much longer, and this might be the bottleneck for mainnet. So what we should likely do is we should run this state test on not a small state, but actually on a very big state, and then see if we can reproduce how slow this is on mainnet. And what I'm doing in the meantime is figuring out if there is something else going on. For instance, like we have some logs, maybe there is some extra log data, which might also be a bottleneck. But in the end, I want to create like a state test that we can either completely rerun this entire transaction, isolate it, or to figure out, okay, if there's something else, something very weird going on, something very exotic in the EVM, that I create an even more compact version of this test that we can really squeeze out, the worst case behavior of the EVM. Yeah.
That's great. Thank you for that. But okay, that sounds like we are still in the reproducing the issue phase and not necessarily in a proposal of solution phase, right? Yeah, Ben, do you want to go?
Yeah, so I lost internet at home while I was at the conference, and so when I came back, I restarted it, and I did run this block. Unfortunately, I didn't trace it, but I processed 23 blocks, which included the problematic one in 600 milliseconds. So I'm not sure exactly what the problem is. I mean, obviously, we did see a lot of validators struggle with it, but we might need to look into it a little bit more to, fully drill down on what the problem is.
So I can talk to what the issue was on Geth. Basically, we have a buffer that we flash to the disk whenever it fills up after 256 megabytes, and this was done synchronously with the block processing, and so often on these blocks the buffer would just overflow because we put a bunch of, like, the likelihood to overflow this buffer to go over the 256 megabytes is very high. And so what happened in Geth is we would just spend 2.5 seconds flushing this block to the disk. And our fix for it is to only flush basically use the double buffering mechanism, only flush the inactive buffer to the disk, and yeah, and switch to the active buffer. Yeah, so that should also take care of this. Regardless of what we're doing, like of how clients actually behave on this block, we should be making sure that yeah, this is that we have good benchmarks for these scenarios where we patch a bunch of stuff in the try all over the try and need to recalculate the state root, and cannot necessarily parallelize it because it's all in the same storage try. But yeah, we will be working on this and try it out on the perfnet to see if there sorry, not on, maybe also on the perfnet, but mainly on the shadow fork to see how the clients behave.
So was it bad timing, or would it have always flushed the that cache?
It's bad timing, but because it like normally blocks don't add that much to the buffer, but these blocks they do. So the chance of them flushing the buffer is much bigger than like a random normal block.
But that also means higher the gas limit, the worse this gets, right? Unless you make your buffer significantly larger.
No, we kind of, well, when the way we change it is we will just flush this buffer asynchronously, not synchronously.
Got it.
And so we don't stop the main processing thread on it anymore.
Okay. Mhm.
Yes, so this buffer flush, that's the state tree buffer, right?
Yes, that is state tree buffer.
Yeah, okay, cool.
Okay, I guess we should have some more insights on this by ACD on Thursday, so I guess we continue the conversation there.
Yes, I will make sure that that I will check if there are like other weird things happening. But I think also from Marius' point just now that it is indeed the well, a lot of state rights and in these random contracts, or not random contracts, but like yeah, there's like a very big state growth here. So yeah.
Yeah, thank you. Cool. Anything else on the gas limit topic? Okay, if not, then let's move on to PRS testing. I guess we did Fusaka earlier. That's mainly PRS testing. I actually think that was the entire agenda. Do we have any other topics we want to bring up today? Yeah, I think we might have an update on history expiry. 1 second on that. Yeah, here's Matt with latest on history expiry.
Hello. I just want to share some of the things that we talked about last week at Interop, just in case anyone who wasn't there was hoping to get caught up. Basically, we talked about what the path forward for the pre-merge history expiry is. Essentially, all of the clients have implemented what's necessary to do pre-merge history. There's like various things that each client has implemented, and maybe there's not like perfect alignment on every feature that every client has, but ultimately, like every client can run without the pre-merge history in one way or another. So we have a path to having all the clients choose to run without that history. So basically, now what we've said as of last week is that clients are free to begin making it the default mode to run without the prune history. They can release this at their convenience. In the next week or two, we'll have a blog post for on the Ethereum Foundation blog, just sharing that it's possible to run clients without the pre-merge history and sharing how to run on the clients that we typically release information with for the fork blog posts. So we'll publish that in the next couple weeks. I think most clients have implemented E69. This is a kind of nice thing to have with respect to starting to drop the history, because now you're not potentially asking a lot of your peers who just don't have the history. You can know ahead of time whether or not your queries are going to succeed. But this is not a requirement for us, having everyone drop the pre-merge history. So that's kind of all that we agreed on for how to sort of close a pre-merge. Then post-merge, we talked a little bit about what we wanted to happen there, and we kind of agreed that we would merge and then we would use the era files as the post-merge. And after talking about it a bit more, we kind of realized that it might just make sense to have separate era files for each layer. So the execution layer will have a file that's storing all of the historical data related to it. And the consensus layer will have an era file with all of its historical data necessary. So we kind of are calling these the era E and the era C files. We have a rough idea of what this will look like on the execution layer. Yasik is kind of the person who's been looking at this for the consensus layer, and I think he has a rough idea too. So over the next 1.5 months, we really want to settle on what that specification is, because that's going to unlock the ability of clients to start pruning more history. Basically, we want to move to this place where we have a backstop to access the history for whatever reason, and it's then it's sort of up to clients to decide how do they individually want to handle history. Do they want to do rolling history expiry first? Or do they want to just support pruning up to, suppose, Cancun? Because, before Cancun, we were using call data for L2s, and there's kind of a lot of call data in that period of time. So we just want to give it to clients to have the ability to make those decisions. And the thing that's on the critical path is just agreeing on what is this shared format we're going to have to import and export that data. So hopefully that is something that will be settled on in the next month and a half by the end of July, and then clients can really start to do whatever they want in terms of history expiry. Era itself is not the only long-term solution that we want to have. We do want to have some more decentralized and robust way of accessing the history. And this is kind of what the Portal network has been designed to provide us for a long time. And talking with clients throughout the week and trying to understand where their Portal implementations are and what sort of needs to be done to get it into a place where it can be relied on by execution layers has sort of made us feel like we need to, from first principles, think a little bit about what exactly is Portal trying to provide, because Portal has a long list of features that's very useful for individual, independent Portal clients, but there's a very small subset that's useful for execution clients. And some things like serving range queries was not even, supported by out of the box, given just how the distribution of blocks are put on the network. So we want to make some changes to exactly these small subset of Portal features that are extremely useful for the execution clients, and then integrate this more tightly into the execution layer. So we want to try and modify Portal so that it doesn't rely on an external light client system, and it doesn't share the header proofs for every block, just to focus on giving value to the execution layer. And then at a later point, we'll start to slowly add back these features in as they become necessary. So we're planning to have a public community call about Portal either later this week or early next week to discuss these types of changes. But this is kind of the types of conversations that we had throughout the week last week. And yeah, I think that's pretty much where the history expiry project is right now.
Thank you. Does anyone have any questions for Matt on the history expiry topic? Okay, then I guess we wait for the community call, and in case you had any questions until then, please reach out to Matt. If not, bring them up at the community call. That being said, I think that's all the topics we had for today. So if there's nothing else people wanted to talk about, then we can end the call a bit early this week. Thank you, everyone. Oh, yep. Yeah, okay, that's a bye. Okay. See you. Bye.